Welcome to Georgia Highlands College Math 97 and Math 99 video tutorials. In this video segment, we'll also be answering the question, how do you solve rational equations? This will be our third example of solving a rational equation. In this particular rational equation, we're going to see what it looks like to have no solutions to the equation. So we'll go through the same steps that we've been through in the other two examples. We'll list our restrictions where the denominator cannot be equal to 0. We'll clear fractions by multiplying every term by the LCD. We'll solve the resulting equation and reject or check and accept the solutions. Let's take a look at our example. All right, so we have x over x minus 3 equals 3 over x minus 3 plus 9. First thing I'm going to do is make everything look like a fraction there by just putting the 9 over 1. And now I'm going to check for restrictions. Well, I have the first denominator of x minus 3, and that cannot be equal to 0. So I simply solve this equation here and figure out that x cannot be equal to 3. I have another denominator of x minus 3, so I'm just going to leave that off because it's going to give the same result as that first one. And then I'll just note that 1 is not equal to 0, so that does not matter in regards to trying to identify restrictions on the variable. Now we move on to clearing the fractions out, so we need to figure out what the LCD is before we do so. So I have a denominator of x minus 3, and that particular denominator has one factor, and that is x minus 3. And then I have a denominator of 1, which is simply a factor of 1. So my LCD is the product of all of the factors of all of the denominators, which is just 1 times x minus 3. So x minus 3 is the LCD. Now I'm just going to rewrite my equation, leaving room to multiply by my LCD for every term. And I'm going to go ahead and put these in parentheses just to show that those are factors themselves. So I come back and multiply every term by the LCD of x minus 3. Just to remind you, this happens in the numerator, so I'm just going to extend my fraction bars to show that that's happening in the numerator. So anything divided by itself is 1. Anything divided by itself is 1. I am left with x equals 3 plus 9 times x minus 3. I need to distribute that 9 to both terms inside the parentheses, and I get x is equal to 3 plus 9x minus 27. Well, I have like terms here, constant terms that I can combine. 3 and negative 27 give negative, there we go, give negative 24, I almost wrote 42, plus 9x. I'm going to subtract 9x from both sides to gather my variable terms on the left-hand side. And that gives negative 8x equals negative 24. Divide both sides by negative 8. And my result is x equals 3. So my next step is to check against any of my restrictions. And sure enough, I have a restriction of x not equaling 3. Because if I were to take this 3 right here and plug it in to either of those denominators, you can see that it would immediately create 0 in the denominator. And that is an undefined situation. Therefore, 3 is not a solution to our equation because it creates an undefined situation. So I simply write that there are no solutions, or I can write the empty set, which is the set that contains no elements there, so no solutions. Either or is an acceptable way of answering this problem here, and I hope that this has been helpful. So we have now seen our third example of solving rational equations, and in this particular one we had no solutions to it. Sometimes you might end up with a potential of 3. One of them doesn't work, so you're left with 2. You may be left with none if none of them work due to restrictions, or you could be left with all 3. If all 3 of your potential solutions do not fall in your restrictions, then they're all acceptable solutions for the equation. If you have any other questions about solving rational equations, please contact your Highlands instructor. Thank you.